The service life of the component is calculated with winLIFE. The weld seams are of interest. The following procedures are used. In this example, the service life of the following structure is simulated. It is a welded model that is cyclically loaded by a force. The model was built in Fermap and consists of shell elements. The different sheets are assigned to several properties. The different sheet metal properties enable automatic weld seams determination. The Fermap winLIFE macro is called. The macro will immediately search for nodes that belong to two properties at the same time. All elements of the model are included in the search for weld seams. The weld seams are found after a few seconds. The video has been shortened at this point. The weld groups are now available. The stress on the weld elements are now exported from Fermap. To do this, the Fermap winLIFE macro is called again. First of all, we use the hotspot method to calculate the weld seam. The critical areas of the component are to be determined. A more precise calculation of these critical points is carried out later using the structural stress concept. An export file for winLIFE is specified. The load case is selected. Here you have the option to choose all the elements. This is useful if the weld groups are not yet available. In our case, the seam groups were searched for earlier. Therefore, the seam group can be selected. A seam line can also be selected manually. This is useful if a weld seam exists, but there are no different sheet metal properties adjacent to the seam. We create a new project in winLIFE. It can be named example 22. The method is determined. The hotspot process works according to the structural stress concept. First, we will use the file exported from Fermap, the LST file. There is only one load acting on the component. The SN curve is generated. More precisely, the Wöhler curve is generated according to the FKM guideline. Here we are using the 6th edition of the FKM because it was used in the associated text document. Bending applies to general loads. The material data is entered. The component class is based on a comparison of the weld seam geometry with the table according to FKM. The residual stresses are set to be high, it's more conservative. The sheet thickness in the model are different. The value 20 mm is an average. A4 is selected for T-joints that remain unpolished. This time we do not choose a safety factor in order to be able to compare the experiments. The SN curve is generated from the inputs. You can see that on the left. The protocol with the calculations for the SN curve is available. The failure probability according to FKM is 2.5%. We are now converting the probability of failure to 15%. Then the comparison with the experiments succeeds. The fatigue strength values change. The load is indicated. We are accessing an existing load file. The load file contains 5 cycles. The calculation results which winLIFE determines later is multiplied by 200. This means that 5 times 200 equals 1000 cycles act on the component. Here in the plot are the 5 swelling cycles. The link with the FE data is now created. The stresses were exported from FEMAP. This file is now specified. The force in the FE calculation was 100,000 numbers. winLIFE then divides the stress in the LST file by this value, and then does the multiplication with the load. The perpendicular to the weld seam is indicated and the geometry file. Information about the calculation parameters now follows. The elementary SN curve form is used. The resulting static overload is ignored here. The level of load is divided into 100 classes. With the reclassification, it is achieved here that 5 complete cycles are calculated. The result is there. 94 times 1000 equals 94,000 cycles are bearable. The damage could be shown in the winLIFE viewer, but here we are tracing the results back to FEMAP. This followed by FEMAP settings. The winLIFE results are entered. So this is the amount of damage. This is maximum in the bend of the frame corner. Now the winLIFE project will continue to be used. The input of the Nastran OP2 file should be shown. The Nastran OP2 file is entered. The other settings remain. The OP2 file is entered. It was generated using the calculation with FEMAP Nastran. By default, the process is set to hotspot. The viewer shows the model. The automatic search via sheet metal properties identifies the weld seams. The node set and the element sets found can be seen here. The check mark in front of the element sets indicates which seeds should be calculated by winLIFE. With OK, the set selection is accepted with a tick. The service life is determined. The model with the results is opened in the winLIFE viewer, if the additional modules is available. The structural stress concept is now used to calculate the locations found more precisely. The FEMAP nodes have already been defined as a group. These nodes are at fixed positions in front of the weld seam. The FEMAP winLIFE macro is used. The export is carried out for the shell elements, which are called plates. The linear extrapolation of the structural stress concept is used. A file is specified. The load case is selected. The appropriate nodes are selected. These are the nodes of the first node's line. The nodes of the second node line are used. With these nodes, the stress extrapolation is then carried out on the weld seam. Again, we use our project and pay attention to the method setting. The SN curve is changed because the sheet thickness is 12 mm at the critical point. The other values are not changed. We select Generate. As before, the probability of failure will be reset to 15%. The FEM results are called up. The stresses from FEMAP are given, or more precisely, the LST file exported from FEMAP. The normal direction to the weld line is also given in the LST file. The mesh information is made available to winLIFE. The calculation takes place. The damage is imported into FEMAP. FEMAP settings are set. The work with the OP2 files should now be shown again. The OP2 interface is used. The OP2 file is entered. Linear extrapolation of the stresses is selected here. The factors shown here are multiplied by the sheet thickness. This results in distance in front of the weld seam. The stress interpolation takes place at these intervals. The stresses on the weld seam are then extrapolated. The automatically found weld seam lines are shown. Additional welds can be specified if required. For this purpose, node sets would be created. Only 2 seam lines are given for calculating the service life. The calculation is started. The result is there. The result is displayed, whereby only 2 weld seam sets were calculated. Here is a summary of the results of the several models compared to test results.